Okay, we're going to be working here, sorry about that, with some uh, Chapter 8 review. So first in Chapter 8, we have the first section, which is talking about direct and inverse variation. And let me explain what I say how I think about direct and inverse variation. When it says whatever value it says, and I think one of the common mistakes students make is they don't read carefully, is it x varying directly with y or y varying directly with x? And so you kind of see those examples both ways, and we'll interchange those, okay? And it doesn't even have to be an x and a y. So whatever varies directly with the other is that there's a rule that says x varies directly with y, meaning that if y is multiplied by a value, it equals x. So our idea, our charge, what we have to do is decide, hey, what is this k? What is this constant that is multiple of y equals x? So first what I do is they say, okay, I know this rule, that when x equals 9, y equals 18. So when this is a 9, y is an 18. So what would k have to be for when I multiply it by 18, I get 9? And the answer is that k would have to be 1/2. So now I'm able to, and I'm ready to write a rule. So for this particular problem, my rule is that my x will always be 1/2 of my y. And then what they do, or how you show them that, yep, I got this now, is they'll say, now apply your rule. Like come up with the rule and you apply it. And it says when x equals 6, find y. So if x is 6, 1/2 of what equals 6? Okay, and the answer is 1/2 of 12. So my answer here is that y would equal 12. Now in the next problem, it says x varies inversely with y. And that one, inverse variation, means that if I take a constant and divide it by my y, I would get my answer. So x equals k over y. So now they say, okay, for this rule, I know this, that x equals 4 when y equals -16. So 4 would equal some k divided by some -16. So I can figure out here that my k must equal, let's see, 4 times 6 is 4, 2, 4, 64, -64. So now again, I have a rule. My rule is that x would always equal a -64 divided by my y. And then they say, okay, apply it. Now your rule, find x when you know your y is 8. So in this case, my x would be -8. So having an answer here of -8, I think it was x equals -8, says, okay, I knew the rule and I applied it well. Let's go through one last one, and that is joint variation. So joint variation starts with this idea that the first value, in this case z, varies jointly with x and y. And usually it's y varies jointly with, or x varies jointly with y and z, so they do change it up. So z varies jointly means z equals, and then the jointly means we're multiplying all three together, the constant times the two other values. It's a lot like varies directly, but there's more than one variable involved. So then they give us a scenario. Z equals 42 when x equals 3 and y equals 2. So 42 basically equals some value times 6. Well, that means my value had to be 7. Excuse me. So my rule is now that my z equals 7 times my x times my y. And then they say find z when x is -6 and y is 2. This is 42, 84. -84 is what my z is. -84 for my z. So that was kind of just, it's kind of thrown in there, but it's still an important idea. It definitely comes up again and again. And the next thing we're saying is, okay, in these type of equations, all right, if I had an equation y equals 1 over x, all right, the way that it's graphed is it's graphed kind of like this. That's basically my parent graph here, 1 over x. And a big part of here is when it's 1 over x, you can never divide by a negative number. And so a big part of this is that I have this asymptote. You can never get a 0 or put in a 0 for your x, and you never can put in a 0 or get a 0 answer for your y, because x would never be a 0, so you're never going to get a 0. So that creates a horizontal and a vertical asymptote. It kind of is an asymptote is that line that your curve approaches but never crosses. So it always comes closer and closer, but it's never going to cross. So then we're given this problem, and we're said, okay, first describe the transformation. This plus 2 here means, and it's kind of on a technicality considered in a grouping symbol. I know there's no grouping symbol there visual, but when it's in the denominator, it's considered part of a grouping symbol. So it's oppositeville. So we're going to go left 2, and that means your asymptote goes left 2, all right, or kind of the whole curve does too. The 3 means that we have a vertical stretch of a factor of 3. And we'll kind of see there's some ways to decide how that looks. There's a bunch of ways to say what your domain is. And usually in domain it says what works for your x's. And so one way is to say x could be greater than or equal to, oh, I just messed up, can't be equal to 0. So x could be less than 0 and greater than 0 at the same time. What does that mean? Well, really what that means is that my x can't be 0. Sorry, your denominator can't be 0. I apologize, I have the wrong answer here. In this case, my x can't be a -2 because that would make my denominator 0. So my x has to be less than -2 and greater than -2, but not equal to -2. Now there's some argument and some discussion whether we could just leave it like this and say, well, x can't be -2, it can be everything else, or whether you should list it like this. Leave that up to your own math teacher, especially when you're going to your next course. I'll go ahead and I'll allow either one. In the range, what are the possible answers I get out? Well, I know my denominator will never be 0. It can't be 0. So I know in this case I'll never have 3 divided by 0. So in this case my y can't be 0. And that's another way to show it. Again, we talked about, well, I'm not going to have space, just put it there. We talked about that I could have listed it as y can't be 0. Horizontal asymptotes. Let's do this on the visual first. So we've talked about how an asymptote usually goes through 0, 0, unless there's been movement. And we can move this, and it kind of does move together. So if we start at 0, 0, we talked about it, it's gone left 2. So that's what happens to our asymptote. It also goes left 2. So our horizontal asymptote is this asymptote here. All right, that's my horizontal. It's on the horizontal. And that horizontal asymptote is a y equals line. And so that's at y equals 0. And the vertical asymptote is an x equals line. And that's at x equals 2. Now look here, I had x can't be -2 and x can't be 0. And look, my horizontal asymptote was y equals 0 and my vertical asymptote was x equals -2. They align with what you can't have for your x or for your y. Our last step here is to graph these. All right, so we have to graph them. So the first thing we're going to do is we're going to say, okay, how do these look? Where would they be? And the idea is that they're going to be up here and over here, all right, on either side of my asymptote. And you start and think about where's your x asymptote? We're at -2. So I want to see what happens to the right of that. What happens at -1, at 0, at 1? And then we're also at -2. I want to know what happens to the left of it. What happens at -3, at -4, at -5? Okay? And so what I'm saying to myself is, what is y when 3 is something plus 2, and I'm going to kind of keep putting different things in here. So the first one was, what is it when it's -1 plus 2? So -3 over really 1, it would be it'd be a 3. Oh, and how did I do that? I don't know how I did that. Okay, there, 3. Then we go do this, we get rid of it, and we say, okay, what if it's 0? It'd be 3 over 2. It'd be 1.5, all right? What if instead it's a 1? See how I'm going down the line there? 3 over 3, it'd be 1, okay? What if I'm at -3? I'm at 3 over -1 or -3. What if I'm at 4? Sorry. 4 here. I'm going to start. All right. -4, I apologize. It would be 3 over -2. And so that would be -1.5. And at 5, -5. It'd be 3 over -3, which would be -1. Now if I go ahead and I graph those, All right, so I'm going to say, okay, I'm going to graph all those. Negative 1, 3. 1, 2, 3. I'm up here. 0, 1.5, right there. 1, 1. You can kind of see how it curves. Now this one kind of got pulled in closer. It's pretty tight to my asymptote. That's what that 3 in the numerator did. Okay. Then I was at negative 3, 1, 2, 3. Negative 4, negative 1.5. And negative 5, negative 1. So you can kind of see it does curve. And these are sketches. I know mine aren't going to ever look perfect, but we're looking for a sketch. All right, again, we're going to do the same process. First idea, let's look at what happens to our transformation. I'm going to start with the transformation. That plus 2 at the end means it's going to go up 2. The minus 4 in the denominator, remember that's part of a grouping, it's going to go right 4. And then the negative 1, really what it's going to do is the non-mathematical way, it's going to be in opposite corners, what we're used to. All right, that's non-math speak, opposite corners. The math speak is there's going to be a flip across the x-axis. Okay, so instead of having it in the first and the third quadrant, it's going to be in the second and the fourth quadrant if you think of quadrants. All right, so now let's think about that in a visual. Let's say, okay, this is where we start with our asymptotes if you are in a parent equation. This is 1 over x. But here, because of the plus 2, it's going to go up 2. And because of the minus 4, I'm going to go right 4. 1, 2, 3, 4. That's my new asymptotes. Okay? That's my new guidelines. There. So, my domain. What can x not be? X can't be a 4. So my domain is that x has to be less than 4 and greater than 4 at the same time. It can't be equal to 4. My range. Well, I'm never going to get a 0. So first you kind of have to think, what happens if I get a 0? And so the answer isn't just 0, because like this can't be 0, but the whole thing could be 0 because at the end you add 2 to it. So my y, sorry, I should have had a not, can't be a 2 because it's like that 0, it can't be a 0, add it plus 2. Okay? So my y has to be less than 2 and greater than 2, not equal to 2. Okay. Horizontal asymptote, remember how they match these? So the horizontal is a y equals line, it's a y equals 2 line. That's where it can't have. Vertical asymptote, x equals 4. X can't be equal to 4, so you're going to have an asymptote on there. Our last step is to graph it, is to say, okay, what goes to the right of my vertical asymptote, what goes on to the left of my vertical asymptote. To the right of that x equal 4 is 5 and 6, 7 maybe. To the left is 3, 2, and 1. All right, and magically they're going to appear. All right, so we just need to graph these. So we're going to be at 5, 1. Here we would be. I'm going to get a better color here. 5, 1, sorry. 6.5, so it kind of goes down. And so, oh, it should be 1.5, 1.66. Basically, this is what happens. Really, really close. That negative 1 in there makes it a little bit, kind of, not as close, makes it a little close. Then the meat of this, okay? In fact, I think what I'm going to do is I'm going to truncate this and I'm going to make a second video.